Okay, this lesson is about gravitation. Okay, gravitation. Maina, what is gravitation? What is gravity? Understand the difference between gravitation and gravity. Gravity is the acceleration due to gravity. A, which is 9.8 meter per second square, is the earth is going to pull any body towards its center. Can we fly? No. சும்மா வந்து ஃப்ளை பண்ண முடியுமா? ஏர்க்ராஃப்ட்ல ஏறி உட்காந்தா தான் ஃப்ளை பண்ண முடியும். Because the earth is constantly pulling us towards the center. So that's what is gravity meaning. But gravitation is every body will attract every other body. It's not only earth. It can be earth and moon, earth and sun, sun and moon, you and me, every body in this. This is called universal law of gravitation. Universal law of gravitation, which states that every body in this universe attracts every other body with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This is m1, this is m2, and the distance is r. The force of attraction, this body will get attracted towards this body, this body will get attracted towards this body. Every body is, another you are here and I'm here. Okay, so that's about it. Every body in this world gets attracted by every other body with a force which is directly proportional to the product of masses and inversely proportional to the square of the distance between them. F is equal to capital G into m1 m2 by r square, where capital G is called gravitational constant, which is 6.6 into 10 to the power, what class you are in? 11th standard, minus 11. Newton is the SI unit for force, meter square is the SI unit for r square, per kg square. This is the value of capital G. Okay, and it's attractive. So they understood the basic difference between gravity is the acceleration involved when the force with which earth is pulling every body towards its center. But this is not just earth. It's about every object in this universe is attracted by every other being. It can be earth and moon, earth and sun, me and me, everything. And that's capital G. Now, next is, let me teach you, is gravitational shielding possible? See, there's something called electrostatic shielding. Electrostatic shielding. You go and if lightning is flow of charge. You know, cloud the charges, electrons are flowing. That's what is lightning. நீ வடிவேலு காமெடிலாம் பார்த்துருக்க, லைட்னிங் அடிக்கும்போது அப்படியே ஃபுல்லும் அப்படி கறி மாதிரி ஆகிடுவான். அது தண்டர் ஸ்ட்ரைக்ஸ்ன்னு சொல்லுவாங்கள்ல அது. பட் ஆனால் அதுலேருந்து ஒன்று ப்ரொடெக்ட் பண்ணிக்கணும்னா என்ன பண்ணும், குடுகுடுன்னு போய் ஒரு காருக்குள்ளே போய் உட்காந்துக்கணும். பயங்கரமாக மின்னல் அடிக்குதா, உடனே ஒரு காருக்குள்ளே போய் உட்காது. ஏன்னா அந்த கார் ஆக்ட்ஸ் லைக் அ மெட்டல் cavity and protects you from the charges. So there's shielding possible for charges, but gravity shielding is not possible. You go and sit inside the car, the gravity will not pull you down. You will float in the car. Only in the space you will float, not here. So then definitely gravitational shielding is not possible. You understand? Gravitational shielding is never possible. Electrostatic shielding is possible. That you will learn about this next year, about sitting inside the car. This is general knowledge. நீ வெட்ட வெளியில் போய் நின்றுக்கிட்ட மின்னல் அடிச்சுன்னா நமக்கு அப்படியே இறந்தி போயிடும். ஜோக்காக காமிக்கிறாங்கல்ல, கருகி போயிடும். அதனால் உடனே போய் ஒரு காருக்குள்ளே போய் உட்காந்துக்கணும். மெட்டல் கேவிட்டியில் உட்காந்தோம்னா நமக்கு ஒன்றும் ஆகாதுங்கிறது ஜெனரல் நாலேஜ். Okay, gravitational shielding. Now I'll teach you this in vector form. Supposing two masses are there, m1 at a position vector r1 and m2 which is at a position vector r2. The m2 will be attracted by m1 and m1 will be attracted by m2 by universal law of gravitation. So we'll call this force where m1 is getting attracted by m2 as F12, force on 1 due to 2. This will be force on 2 due to 1. Well, let's write F12, force on 1 due to 2 is capital G into m1 m2 by position vector r square. You should write in vector form. When you have F12, you should write r21 vector the whole square. See, ஒரு கார் வந்து இன்னொரு கார் வந்து டங்குன்னு அடிக்குது. இது ஃபஸ்ட்டு கார், இது செகண்ட் கார். போலீஸ் வந்தோடனே இங்கேருந்து மெஷர் பண்ண மாட்டாங்க. இங்கேருந்து வந்தான்ப்பா, இப்படி வந்து இடிச்சான்ப்பா, இவன் தான் அஃபெக்டட். பிகாஸ் ஆஃப் இவன் அஃபெக்டட். பட் மெஷர்மெண்ட் இஸ் மேட் ஃப்ரம் 2 to 1. F12 you should have r21 vector the whole square into r21 cap. இந்த cap எதுக்கு போடுறோம்? A vector when squared becomes a scalar. Minus sign also when squared becomes plus sign. Like that a vector direction போயிடும். அதனால to retain the vector form you are writing r21 cap. Cap is a unit vector. Cap னு போட்டாலே it's a unit vector. So this about, next let's talk about F21. How the second body is getting attracted by the first body is G into M1 M2 by R12 vector the whole square into R12 cap. Okay, that you know that these two are equal and opposite. R21 is minus of R12. Therefore, F12 vector is minus of F21 vector. They are equal, and also negative sign shows that they are attractive. The negative sign is attractive, you should have a negative sign. Are you clear? So this is what happens in superposition of forces. Superposition of forces means, supposing you have number of bodies, such as you have a body M1 which is at a position vector R1, a body M2 which is at a position vector R2 from the origin, a body M3 which is at a position vector R3, a body Mn which is at a position vector Rn. First body is going to be pulled by the second body. First body will be pulled by the third body. First body will be pulled by the nth body. Like this, first body is getting pulled by every body. So the force on the first body is force on the first body due to second body, force on the first body due to third body, force on the first body due to nth body. So let's write this. G into M1 M2 by R21 vector the whole square into R21 cap. Next F13. G into M1 M3 by R31 vector the whole square into R. The opposite are 1 2 not 2 1. 1 3 not 3 1. 3 1 cap. Plus dot 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 G into M1 Mn by R N1 vector the whole square into R N1 cap. This is force on the first body. Let's write the force on the second body. We have done only for first body, but it is understood that you can also draw for the second body. Second body will be attracted by the first body. Second body will be attracted by third body. Second body will be attracted by the nth body. The force on the second body will be because of force on the second body due to first body, force on the second body due to third. Don't say force on the second body due to second body. I won't exert a force on myself. And force on the second body due to nth. Comfortable. Okay. So that's right. This is the force. What is it? G into M2 M1 by R12 vector the whole square into R12 cap. G into M2 M3 by R32 vector the whole square into R32 cap. G into M2 Mn by Rn2 vector the whole square into Rn2 cap. Like this, you can write the force on the nth charge, nth mass. Force on the nth mass due to first mass, force on the nth mass due to second mass, and force on the nth mass due to n minus 1th mass. When you substitute all this value, you will see that everything has got G, everything will have M1 M2. So I'm going to add all these forces, F1 plus F2 plus dot 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 Fn, where I'll have G. M1 M2 I'll write as MA into MB, because it can be 1 2 2 3 3 4 whatever. Correct? A can be 1 2, B 1 means B can be 2, B can be 3. So I'll write MA MB by RBA vector the whole square into RBA cap with a summation, where A is ranging from 1 to n and B is also ranging from 1 to n. But A is never equal to B. Obviously it will be M1 means there will be M2. 1 and 1 is never equal. So summation means you're going to add all this. So this is called a superposition of forces. Number of masses are there. Are you clear? So I'll give you a proper PDF also and this recording also. Interrelate both and study. Don't see the Arura or don't learn from the textbook. After you are so clear with all this, then you can do I know this, like that you can see. But first, whatever I'm teaching is primary. Okay, so let's go to next term. Next thing is superposition of forces is over. Okay, next is shell theorem. Very, very important. The lesson actually starts with shell theorem. Shell theorem na enadhu appadinaka, you have earth which is like a sphere or any shell also. You can talk about earth or you can talk about any shell. So supposing you're trying to find this is small mass m and this is a capital mass m. There is separation. This is center O and this point mass m is situated at a point P which is at a distance r from the center. Always the point mass P will be situated only at a distance r from the center. Physics முழுக்க அப்படிதான். Any point P will always be r from the center. So that's what it is. Now they want to find the force due to this sphere and this mass between this. You know, it's F is equal to G into capital M into small m by r square. That's all. And this is what you understood. Supposing I write it as vector, you can write it as r cap. That's all. So now what happens then? This point P is located on the surface. The small r will be equal to capital R. If the point P is lying on the surface, you can write small r becomes equal to capital R. Therefore, the force will be G capital M small m by capital R square.
R capital R.
Capital R is the radius of the mass sphere. M capital M is the mass of the earth, bigger sphere. Supposing this is earth, capital M is the mass of the earth, capital R is the radius of the earth. But small r is the position vector of any arbitrary point P. Okay, so then replace small r square as capital R square. Now what happens when the point P is located interior to the sphere? At a position vector, small r from the center. Okay, so then you should know that capital M is the mass of the entire sphere, and you have to construct a sphere which is where the small m is located. Only the part of the mass interior to the point P will attract the small m. அவுட்சைடில் என்ன இருக்கோ இட் நாட் அட்ராக்டாக உன்னை பிடிச்சி நான் இழுக்கணும். நான் தான் அந்த ஸ்பியர், எனக்கு உள்ளே இருக்கிறதுன்னு உன்னை பிடிச்சி, வெளியில் இருக்கிறத பிடிச்சி இழுக்கும், வெளியில் இருக்கிறது தள்ள தானே செய்யும். அது இட்ஸ் நாட் அபவுட் தட் ஃபோர்ஸ், இட்ஸ் ஒன்லி அபவுட் அட்ராக்டிவ் ஃபோர்ஸ். ஸோ தேர்ஃபோர் the part of the mass which is interior to the point mass small m, which is called dm, is what is going to contribute to the force of attraction. So in this, when I write F, it is capital G into capital M எழுத முடியாது. dm, the proportionate mass which is interior to the point P, into small m by small r square.
ஆனால் dm எழுதணும்.
அது திஷல் தியரம். இதை சொல்லிட்டு இருக்கேன். When the point P is located interior, only the mass of the earth which is inside the position P will contribute to force of attraction. Not what is exterior does not even matter. So அதனால இந்த dm கண்டுபிடிக்கணும். என்னடா அது dm? M capital M is the mass for 4/3 pi capital R cube, bigger volume. Then the dm is a smaller mass interior which is 4/3 pi small r cube. Do like this, unitary method. So just cross multiply. M into 4/3 pi small r cube is equal to dm into 4/3 pi capital R cube. 4/3 pi get cancelled. dm is equal to capital M into small r cube by capital R cube. You must memorize this dm. If you will know that 4/3 and 4/3 will get cancelled, pi and pi get cancelled, m into capital M into small r cube by capital R cube. Either you should memorize. I told this boy also, did you write that? I asked him. Capital M into small r cube by capital R cube, substitute that here. So F is equal to G into capital M into small m into small r cube by capital R square, capital R cube small r square. This and this get cancelled. Thus the new force inside, you're getting it like this. From this you know this is constant. Capital G will not change. Mass of the earth was fixed value. Mass of the body is fixed value. But small r can change. Therefore the force is directly proportional to r when the point mass is situated inside the earth. Whereas the force is inversely proportional to r square when the point mass is situated outside. This conclusion is called shell theorem. And to write this, you have to do a combined graph. This is the earth. We are doing a graph between force and r. And inside, when a small r is less than capital R and small r is greater than capital, because here is radius r. Here it is linear straight line directly proportional to r. Here it is inversely proportional to 1 by r square. Inversely proportional means graph will be like this. So this is the graph. You should memorize this graph and go. F is directly proportional to r inside, and to the outside as it goes, becoming inversely proportional. This graph is very important. This, write a note on shell theorem, means all this, but mainly this. That is the mass which is interior to the point mass m is what is going to contribute to the force of attraction. The whole point is to find that dm, which obviously you know by unitary method is capital M into small r cube by capital R cube. Substitute that in the force, you get this, and you conclude that F is directly proportional to R inside of the solid sphere if your body is inside. Supposing we take a stone, the earth is here, I keep the stone away from the earth. There is a distance R, so it's inversely proportional to R square. Now I dig a hole and I bury the stone inside. The force will be directly proportional to R. As the person inside of the earth, as R is increasing, the force is also increasing. Outside, as R is increasing, force is decreasing. Are you clear? So that's about this. Shell theorem is over. Next is gravity. Gravity at a height. Okay, very, very important. This is the earth. You know the radius of the earth is capital R always. At any point at height h from the surface, height is always calculated only from the surface. We don't go and measure it from the center. No, tape எடுத்து பூமிக்குள்ளேயே தோண்டி உள்ளே போய்க்கிறேன். ஒரு ஹைட்டுனா தரையிலேருந்து தானே பார்க்குறோம், நம்ம ஹைட்டே பார்க்குறோம், பூமிக்குள்ளேருந்து தான் பார்க்குறோம். Surface of the earthலேருந்து what is our height? So h is always from the surface of the earth. I told you this is capital R and this is h. Let's look at this. What is the gravity? Okay. I'll just teach you one general thing, very, very important thing. You know, to find the gravity, how to find small g. You know, the m into g, பூமி இருக்கிற force, earth's gravity is going to pull it. Earth or mass of the body is also universal of gravitation, which is also capital G into capital M into small m by r square. M and m get cancelled. So small g is always gm by r square. You understand? You can equate the gravitation if you are comparing the earth with another body. If there can be also gravity, it can also be gravitational force, capital G vechirudhu. So both the force, gravitational force and the force due to gravity can be equated. Force due to gravity is small m into g. Gravitational force is g into capital M small m by r square. So this formula for small g is damn important. Small g is capital G into capital M by r square. This is on the surface of the earth. It's always on the surface of the earth. Supposing this body is present here, you can write it as capital R square. If this body is far away, you can write it as small r square, depending on its position. Now come back here. What is gravity at the surface? Gravity at the surface, gs nu potukalama, is equal to capital G into capital M by distance is capital R square, because that's the distance. But gravity at a height panna, capital G into capital M by small r square, which is r plus h the whole square. You understand? Yeah, I agree. A small r itself is r plus h. So now divide this equation 1 with equation 2. Gravity at a particular height by gravity on the surface is gm, and gm will get cancelled. This r square will go up.
Minus square.
No minus. Gm by r plus h the whole square by gm by r square. But gm get cancelled. This goes up. So thus you get gravity at a height by gravity on the surface is r square by r plus h the whole square. Very, very important formula.
Numerator வந்து denominator கொண்டு square minus
square minus அதெல்லாம் sure. Okay, so then this you get gravity இப்படி கிடைக்குது. இந்த formula very important. இப்போ how to approximate this formula? approximate பண்ண போறேன்னா I'm going to take r square out. gh by the gravity at the surface is, we can call it as g only. The issue. So you can take it to that side. You get gh is equal to g into r square by r plus h the whole square. இப்போ you're going to take r square out. இந்த r square வெளிய எடுக்க போறேன். இது r கிடையாது, r square. ஏன்னா whole square னு இருக்குல்ல, அதனால when you take it out, it's come out as, so it will come out as
r square.
R square. So gh is equal to, black color dhanna, gh is equal to g into r square by r square into 1 plus h by r the whole square, where r square and r square will get cancelled. gh is equal to g into, இது வந்து மேலே கொண்டு வந்தால் exponents 1 plus h by r whole to the power minus 2. Correct? The 2 will go to the top and become minus 2. ரெக்கார்ட் ஆகுது. சரி, ஸோ இதை வந்து ஹோல் டு த பவர் minus 1 by 2ன்னு போட்டுக்கோ எக்ஸ்போனன்ஸ் யூஸ் பண்ணி. இப்போ பைனாமியல் தியரம் யூஸ் பண்ண, இட்ஸ் 1 minus 2h by r. இந்த 2 மைனஸ் வந்து இங்கே வந்தால் பைனாமியல் தியரம். யூ மஸ்ட் ஹவ் ஸ்டடிட் பைனாமியல் தியரம். ஸோ இது இப்படி உள்ள கொண்டு வந்து ஹையர் பவர்ஸ் கேன் பி இக்னோர்ட். அதனால தான் இது அப்ராக்சிமேட்னு சொன்னேன், பிகாஸ் ஹையர் பவர்ஸ் ஆர் கெட்டிங் ignored. So 1 minus 2h. So gh is equal to, this is an approximated formula, this is also a very important formula. So you should know both the formulas. gh is equal to g into r square by r plus h the whole square. For really big values means you should take only this formula. Something which can be approximated means you can take this formula, g into 1 minus 2h by r. Okay, now gravity at a particular depth. So gravity at a particular depth. So depth il paakkanuna, you take the earth here and consider that we're going to study gravity at this depth. Okay, you know this is at a position vector r, but you know that the radius is capital R and the depth here is d. So small r can be at any time replaced as capital R minus d. So let's write gravity at the surface. What is gravity at the surface? I'm not putting s anymore, you understood now. Is g into capital M by
R square.
capital R square. Be specific. Okay, gravity at a depth. Gravity at a depth means, I told you, only that part of the mass which is interior to it will contribute to force of attraction. So when I write here, I am supposed to write g into, not m, I should write dm. G into dm by position vector is small r square. This is the formula for gravity at a particular day. You understand? M ku badala I should put only dm, and I have marked up dm now. What is dm? Capital M,
Small m, capital M.
capital M into small r cube by capital R cube into this r square. So r square and r gets cancelled, and you know that gd is equal to gm into what is, you get what is r? R is nothing but capital R minus d by r cube. This is my equation 1. This is my equation 2. Divide gravity at a depth by gravity on the surface, g into capital M, r minus d by r cube by so you have to divide it by surface, which is gm by capital R square. Gm get cancelled, r square and r get cancelled. So gravity at a particular depth by gravity is r minus d by r. Gravity at a particular depth by gravity is 1 minus d by r. So gravity at a particular depth is g into 1 minus d by r. It's a formula. Okay.
In m multiply r value in m okay.
Well, gm get cancelled. Gm got cancelled. This is a formula for gravity at a particular depth. I'll send you the video, just listen it. Then now is a case study. There are 2 case studies. So case study number 1, gravity at a particular height can be equal to gravity at a particular depth. Gravity at a particular height formula is gravity on the surface into 1 minus 2h by r, is gravity at a particular depth is g into 1 minus r by dr, 1 minus d by r, 1 minus d by r. I am equating
first 2 videos extra sums முடிச்சிட்டேன்.
gravity at a particular height gravity at a particular depth ஈக்குவலாக இருக்கும்னு அசியூம் பண்ணிக்கும். சும்மா ரேண்டமாக பண்ணால் g and g gets cancelled, 1 and 1 get cancelled, அப்புறம் minus and minus get cancelled. You get 2h by r is equal to d by r. R and r also get cancelled. So 2h is equal to d. இதுக்கு என்ன அர்த்தம்னா, சப்போஸ் எர்த் இங்கே இருக்கு, நீ இங்கே இருக்கன்னா you have to climb, you're climbing 4 meters. இந்த இடத்துல கிராவிட்டி என்ன இருக்கும், அப்போ you have to deep let you have to go 2 meters. So that the gravity at this point and gravity at this point will be the same. You should understand that as you go up and up and up from the surface, the gravity is decreasing. As you go down and down and down, the gravity is decreasing. As you go up also it's decreasing. As you get buried also it is Decreasing, the action, decreasing. So at the center of the earth, the gravity will become 0. That's what is the next proof. So as you go up also it's decreasing, as you go down also it's decreasing, and it happens like 2 times you have to go to that height in order to get understood. 4 meters you have to travel up, and for down you have to go only 2 meters, and the gravity will be the same. That's this derivation. There's one more case study, which is case study 2, is about to find the gravity at the center is 0. You take gravity at a particular depth. Formula is gravity on the surface into 1 minus d by r. Okay, now take LCM, r minus d by r. When depth is equal to full, you can imagine when the depth is full, d is equal to r. So this will become 0. Therefore, gravity at the center is becoming 0. Which gravity is the center of the earth. So which means we will not get pulled, we will be floating, flying or whatever. But of course, we cannot get inside because there are molten metals buried in the earth. The hot boiling temperatures, we cannot even imagine. Nobody has experimented it. It's an imagination, hypothetical situation. Physics is completely imaginative. Certain things can be proved, certain things has to be assumed. So like that, gravity at the center is 0, and we feel weightless at the center of the earth. Therefore, we feel weightless. Okay, so let's go to next topic. These are the 2 case studies. Okay, next is I'm going to teach you what is gravitational field intensity. Gravitational field intensity. Gravitational field intensity is represented by a letter E. Field intensity, E. Intensity I la irundidana E. Bayala paru. Appo E is equal to F by M. Force experienced by a unit mass in bringing it from infinity into the region of the earth where there is gravitational field is there. Earth sutti there is a gravity. This is earth sutti there is a gravitational field region. You're trying to bring a unit mass small m, which unit mass means this mass is just one unity. You're bringing it from infinity. You bring it here. That force with which it's getting pulled inside the gravitational field, because initially it is in the outer space. Infinity means it's in outer space. It will not be attracted by earth. You literally have to pull it. That force by that mass is what is called gravitational field intensity, which is Newton per kg as a unit. Okay, so they understood what is so what is E also? F formula, capital G, capital M, small m by r square, considering it is r square, into small m get cancelled. So you get a new formula, G capital M by r square, where r is the position vector from the center r. This is the r, correct? So that's gravitational field intensity. Next, I'll teach you what is a gravitational potential energy. Gravitational potential energy. Supposing this is the earth. I'm trying to bring a mass from infinity to a point P. P is always at a position vector, R from the center of the earth. Physics mulka P is always, any arbitrary point P is always located at the center, R from the center. You're going to bring it from infinity to this point P. But however, I can't do this directly. In order to do this, I'll try to bring the particle from A to B, where A is at a distance x from the center, and I'm moving it through a distance dx. I'm imagining not from infinity to point P. Instead, I'll bringing it to A to B. So then you know that you should. How do you start? There's a word called energy. Energy in physics means work done. And work done according to your 9th portion is force into displacement. Dx is already your displacement. Instead of F, you can write G into capital M into small m, because this is capital M and the small particle is of small m. By not r square, because you're moving it from A to B, so x square into dx. So, but also, this has got to be negative. Why? Because force is no, let's not write that. Attractive force, let's not write that. We'll write it like this, and then let's integrate it. G capital M small.
Why are we multiplying the dx over there?
dw is equal. Work done is force into displacement is what you studied in your smaller classes. The displacement is this displacement and force. Leftly you should, since there is dx, you should write only dw, you can't write w because it involves integration. So dw is equal to f into dx. So you can write 1 by x square into dx can be integrated. Left side also can be integrated. 1w will be w straight away. But we don't call it w, we call it as potential energy u. W kubala we represent it as u. Integration of 1 by x square is minus 1 by x. Do you know the integration of 1 by x square? 1 by x square can be written as x to the power minus 2 dx. So x to the power minus 2 plus 1 by minus 2 plus 1. The formula for x to the power n integration is x to the power n plus 1 by n plus 1. You should know this. Number where x to the power number plus 1 பண்ணோம் கீழே காப்பி அடிச்சணும். So இங்க என்ன இருக்கு minus 2 plus 1 by minus 2 plus 1. This answer will be x to the power minus 1 by minus 1, which is minus 1 by x. Therefore you know that integration of 1 by x square is simply minus 1 by x. You have to either mug it up or understand and do it, it's up to you. Then you're gonna, it's bringing from a to b. But instead of a to b, I'm up changing the scenario. It's minus 1 by x, right? I'm going to bring it from infinity to r. So infinity to r, abhi change it. Take the minus sign outside. You'll get upper limit is 1 by r, lower limit is 1 by infinity. Correct? So this will get, the answer 1 by infinity is always 0. So therefore you get minus g capital M small m by r, and thus you get the potential. Never put a negative sign for force here. Just put only the magnitude of it and write and integrate it, you get a negative sign. So you get minus g capital M small m by r to be the potential energy. And V is equal to W by M. In 10th standard you would have studied V is equal to W by Q. The potential is the work done bring a charged particle from one end of the conductor to the other end of the conductor, current, electric current. இதுக்கு பதிலா V is equal to W by small m போட்டுக்கோ. அப்போ one of the m will get cancelled. The potential will be minus gm by r. So potential energy is something you can derive. That's what I can derive because I know from where I can start is work done is force into displacement. It makes this very, very easy. Once I derive the potential energy, I am simply able to write the formula for the potential using that and justifying. I am not doing another derivation for potential. This way I am doing. You can check out what is your notes given by your school teacher. If you have any doubts, you can come back and ask. But make sure that you are conceptually clear. So if I teach you A into B is equal to AB, your teacher might say B into A is BA. Don't panic. Physics is physics. How they teach you can vary. You understand? Artha purinjittu you should learn. You should not panic about different notes. Physics is physics. You understood physics? Your teacher teaches like this. You should be able to understand. Now, what is she teaching? Oh, she is doing like that. Oh, my auntie taught me like this, but she is doing it differently. And the interpretation is very, very important. Okay, you can get up and ask, can I also write like this, ma'am? Supposing she tells you a new derivation for potential. You can say, can I just derive potential energy and then write potential from that? Instead of doing one more derivation for potential. One derivation which can be used for both. Smartness. You can ask her. Okay, like this you should question people and then understand. So that's about potential energy. Next, therefore, you know the potential's formula is G. Potential energy's formula is G capital M small m by R. Okay, now next is about escape velocity. Escape velocity. You know, if you're going to launch a satellite, பூமியில் இந்த ISRO இருக்குது. சப்போஸ் இங்கே தான் ISRO situated. From ISRO you're going to launch a satellite means இங்கேருந்து ராக்கெட்டில் பறக்க விடுவோம் சேட்டலைட்டை. செம்ம ஸ்பீடில் பின்னாடி எப்படி கேஸ் வெளில வரும், கம்பஷன் நடக்கும். Due to that high combustion, this thing will start propelling forward. Rocket will go with such a high speed. Imagine that it has to leave the Earth's gravity and go outside. Otherwise the gravity will pull it again down. It has to escape from the Earth's gravity and go completely outside into the space where there is no effect of gravity. Correct? That's called escape velocity. For which, how do you start the derivation? In order for it to escape into the, so you want to find VE, which is the escape velocity. You should start the derivation with See, basically, if this is the Earth and this is the satellite which is getting launched. It should go with that kind of a kinetic energy, half m ve square. That much of a kinetic energy that it can escape from the force of attraction or the work. It has overcome this work or this energy with which this particle is attracting. The mass of the Earth is attracting. What is that work done? You've just found out. We just found out that it was okay. But we have to do this derivation again, because in this we were actually bringing it from infinity to r, whereas in the same derivation you can write in this the second part of the derivation we're taking it from r to infinity. Because you're launching a satellite, the same derivation will continue and you'll write capital R to infinity. So what is the energy due to that is minus, take it out, g capital M small m into 1 by x is from r to infinity. Upper limit is 1 by infinity minus 1 by r with a minus sign here. 1 by infinity will become 0. So it will be g capital M small m by capital R. That is the value now you're going to substitute here. The entire derivation you have to rewrite again. Considering it is getting launched from surface of the Earth to infinity. So you'll get g capital M small m by capital R, which can be equated to half mv square.
Even half mv square.
Kinetic energy with which it can escape into the பூமியோட ஈர்ப்புலேருந்து கம்ப்ளீட்டாக பிச்சுட்டு போயிடணும் இல்லையா. That much energy it should possess. You are trying to equate this is energy and the kinetic energy so that the escape velocity is there in kinetic energy. So small m and small m get cancelled. So it's 2 into capital G capital M by R is equal to VE square. VE is equal to root of 2 capital G capital M by R. This is the formula. You can write this as also R plus H if it's not from the surface of the Earth. But here it is only from the surface of the Earth, correct? So therefore it is R. But you can replace G capital M as small g into R square, because I taught you small g is G capital M by R square. So from this you can write it as GR square. The formula will become root of 2 into G R square by R, where R and R will get cancelled. Thus the escape velocity can also be written as root of 2GR. So in the formula you should memorize. This formula also you should memorize. Root of 2 into G into capital M by capital R. Or because this is getting launched from the surface of the Earth, it should be R plus H if you're launching from somewhere else. But this is BE, which is also root of 2 into small g into capital R. So you should know both of this. Suppose write a note on escape velocity. Now we're going to write, when you're writing in the exam, let capital M be the mass of the Earth, small m be the mass of the satellite which is getting, you'll explain all that. Capital R is the radius of the Earth. Kinetic energy is half m, v square, where m is the mass of the satellite and v is the escape velocity with which it has to escape the outer. There's chinna intro and then write if you have time. If you don't have time, write only the derivations, because time management is very important in physics. You won't be able to complete the paper only. Okay, that next is orbital velocity. Next is about orbital velocity. What is orbital velocity? The planet is going to revolve around the Earth. Planet will revolve around the Earth. We are launching it. What is the purpose of the satellite? Is to monitor the weather in Earth. Sun satellite is actually launched. Can you see this is radius of the Earth, capital R, and this is the height above which we are launching the satellite, so that it is not falling into the Earth. It has to stay wherever it is and try to orbit around. Yes, this is called orbital velocity. Though you're not supposed to say satellite and all here. I'm just giving you an example. For an object to revolve,
take the moon because it's revolving around.
Yeah, we need not say how to generally derive the formula for orbital velocity. We won't say moon, we won't say satellite. We are imagining the moon or a satellite, yes. But we are not saying, we are saying small m is going to orbit around the capital M. We will not say it's moon or whatever it is, because this is a separate topic for satellite. But for you to understand, I have to give an example, so I was giving that. So the small m is revolving around at a height h around Earth. So in this case, we want to find orbital velocity VO. Anything rotating, anything moving out will have kinetic energy half mv square. Anything rotating will have centripetal force mv square by r. Centripetal force. You know centripetal force formula? You should know. Without which you can't do physics. வீட்டுக்கு போய் முட்டி centripetal force is mv square by r அப்படி படிங்க. Okay, one second. Okay, mv square centripetal force தெரியாதவங்களே இருக்கக்கூடாது. Centripetal forceங்கிறது இருந்தால் தான் ஒருத்த சுற்றி இன்னொன்று சுற்றி வர முடியும். மூணு எர்த்தை சுற்றுறதா இருக்கட்டும், எர்த்து சன்னை சுற்றுறதா இருக்கட்டும், எல்லாத்துக்குமே சென்ட்ரிபியூட்டல் ஃபோர்ஸ்னு ஒன்று இருக்கவே இருக்காது. ஓகே, அதனால இதில் அதில் கைனடிக் எனர்ஜி முக்கியம் முந்தின டெரிவேஷனில். இந்த டெரிவேஷனில் சென்ட்ரிபியூட்டல் ஃபோர்ஸ் mv ஸ்கொயர் பை ஆர். ஸோ இந்த mv ஸ்கொயர் பை ஆருங்கிறத சென்ட்ரிபியூட்டல் ஃபோர்ஸ் ஹாஸ் டு mv ஸ்கொயர் பை ஆர், வேர் r is nothing but r plus h. Correct? But this has to be equal. This is a force. So I have to equate it to force. And you know what is the force between two objects? Is g into capital M into small m by r plus h the whole square, where this and the power get cancelled. Small m and small m also get cancelled. VE square is gm by r plus h. VE is equal to root of gm by r plus h is what is called orbital velocity. E போட்டேன், orbital velocity, VO, சுற்றி வர velocity. Very important formula. ஐயோ, I can't tell you how important this is. Let's get this clear. H இந்த height. G capital M by R plus H. This is the formula. இதில் you can write GM as also root of GR square by R plus H, where if you consider H to be negligible, அதாவது என்னன்னா, compared to the radius of the, radius of the earth is 6,000 kilometers. இதை கம்பேர் பண்ணும்போது லான்ச் இந்த ஹைட் கம்மின்னு வச்சுட்டா இதை இக்னோர் பண்ணிக்கலாம் ஹெச். இன் தட் கேஸ் இட் வில் பிகம் ரூட் ஆஃப் GR. இது பார்த்தீங்கன்னா இட் வாஸ் ரூட் ஆஃப் 2GR. தேர்ஃபோர் எஸ்கேப் வெலாசிட்டி இஸ் ரூட் 2 times ஆர்பிட்டல் வெலாசிட்டின்னு ஒரு ரிலேஷன்ஷிப் பிட்வீன் எஸ்கேப் ஆகிறதுக்கும் ஆர்பிட்டலுக்கும் கிடைக்கும். ஸோ ஆர்பிட்டல் வெலாசிட்டி இஸ் லெஸ்ஸர், இஸ் ஒன்லி ரூட் ஆஃப் GR. இந்த மாதிரி இதில் இந்த ஃபார்முலா செம்ம இம்பார்ட்டண்ட். Okay, so next thing that I'm going to teach you is about time period of revolution of a satellite or whatever, so, or even a Mars or satellite or whatever. Time period. If you want to, we'll talk about a satellite and a Mars, okay, or body of Mars and body of Mars at capital M. Time period, time period is 2 pi r by v. Where v is orbital velocity. A, velocity is distance by time. Distance in a rotational motion is 2 pi r. By t is time period. Therefore, time period is 2 pi r by v, where v naught is the orbital velocity. So, the basics that you learnt in 8th standard, velocity is distance by time. So, you write what is time. And then now you know orbital velocity is formula. We have mugged up orbital velocity. I told you it's very, very important. Root of gm by r plus h. Remember, I told you this is something that you need. That's why I was insisting that you learn it well. So then substitute that here. So t will be 2 pi, the small r will be r plus h, by v naught will be root of gm into root of r plus h. You know that this will be 2 pi into, this is r plus h the whole to the power 1. This is r plus h the whole to the power 1 by 2. Therefore, combined together it will become r plus h whole to the power 3 by 2. Exponents. 1 plus 1 by 2 will be 3 by 2. So, you cancel this and write it as r plus h the whole to the power 3 by 2 by root of gm. Now, this 1 by 2 alone, you can write this as r plus h the whole cube whole to the power 1 by 2. 1 by 2 is square root. Is root of r plus h the whole cube nu iruklam. Idu eduthu inga translate pannidren. So therefore it is 2 pi into root of r plus h the whole cube by gm, and this is the formula I am getting for time period. But having said that, this does not complete the derivation. You have to continue. What is mass? Density is mass by volume. Mass is density into volume. Let's replace that as 2 pi into root of r plus h the whole cube by g into density into volume. Volume of the earth is 4 by 3 pi capital R cube. Note this point, when the 2 comes inside the root, it will become 4. And that 4 and this 4 will get cancelled. Or 4 can come outside the root, 2 and 2 get cancelled. However you want to say, you can say. The pi goes inside the root. When pi goes inside the root, it becomes pi square. And this pi and that pi will get cancelled. So, and this 3 will go up. So, therefore, the formula will be 3 into pi into r plus h the whole cube by g into rho. And pi also, pi, what is that pi? This pi comes inside, pi and pi also get cancelled. This pi when comes inside, this pi when comes inside will become pi square. So this pi and this pi, one pi will be there. One pi will still remain there. So 3 pi r plus h whole cube, 0, this 3 has gone up. This 4 has got cancelled. You still have this pi has got cancelled with this pi square. So you have an r cube. So then write it as root of 3 pi by rho g. Write it as rho g. நமக்கு rho g னா ஞாபகம் வச்சுக்க முடியும். rho d. rho d ஞாபகம் வச்சுக்க மாதிரி rho g இப்படி ஞாபகம் வச்சுக்கலாம். By இங்க வந்து you have r plus h the whole cube by r cube. Considering h is negligible or small when compared to r. H is lesser when compared to capital R. You can ignore the h. R cube and r cube itself will get cancelled. The 3 pi by rho g is the approximate formula you will get for the time period in that case study. It's a case study. Last class. This is the formula. And in this, the time period will be, I'll tell you a hint to remember this. 1 மணி நேரமும் 24 நிமிஷமும், which means 60 minutes plus 24 minutes is 84 minutes is the total time taken for the planet to revolve around the sun, approximately only, because we are considering h to be negligible, no? Okay, so then that's the time, approximate time period calculated based on 3 pi and density of the earth is given. Gravity is 6.6 into the power minus 11 and 3 pi is a constant, so 84. இது எப்படி ஞாபகம் சொன்னா, எல்லா டியூஷனும் 1 hour 24 minutes தான் எடுப்பா, மால்தி ஆண்டி மட்டும்தான் விடிய எடுப்பேன் அப்படின்னு சொல்லி சும்மா ஒரு க்ளூ. மறக்கிறது இல்லை நமக்கு, மறக்காமல் இருக்கிறதுக்கு ஏதோ ஒரு க்ளூ. நீ கெமிஸ்ட்ரி டியூஷன்லாம் போறியா? போலி, இன்னும் எந்த டியூஷன் போகல கெமிஸ்ட்ரிக்கெலாம். ஓகே, மேக்ஸ் 1 hour 24 minutes-ஆ? அவ்வளோதான். 1.5 மணி நேரத்துக்கு மேலே ஒரு டீச்சரால் உட்காந்து எடுக்க முடியாது. நான் தான் பீஸ்ட் மாதிரி எடுத்துகிட்டு இருப்பேன். அதனால் அதை ஞாபகம் வச்சுக்கோ. அதை போட்டு 1 hour 24 minutes போட்டு அதை எழுதி விட்டுரு. Okay, so are you clear till time period? Very, very important. Next one, the last derivation for today, I won't torture you more, is about finding this h. Auntie, what the hell, to find h, what is h? This h. Supposing the question is about finding this h. Okay, so how to find that h? You have to approach, time period formula. You remember this formula where we wrote time period is equal to 2 pi into root of this one. 2 pi into root of r plus h the whole cube by gm. Where m we wrote it as density into volume, adil gm. You take this and write it as g r square. You know you can write it g r square. Now what you do is square both sides. Now you write what is r plus h the whole cube. G, there's a t square, a g r square by 4 pi square. Correct? So now what is r plus h? The 3 when goes that side will become 1 by 3. Power like a 3 goes that side will become 1 by 3. Now you want h, take the r to the other side. This is the formula to find the height. I remember this formula because I squared the time and I wrote capital Gm as small g r square, and I had a 2 pi which became a 4 pi here. Okay, just remember this. T square g r square by 4 pi whole the power 1 by 3 minus r is what is height h. That's all for today. Just thorough all this and come. Next is about geostationary satellite. Your teacher must be taking all that in class now. Geostationary satellites. and about Kepler's law and all that. There's another one more part which I have to do. You thorough this and come on Wednesday at 6:30 like this. I'll finish off this chapter for you. And anyway, weekend I'll be doing numericals. Friday I'll be doing numericals.
Gravitation.
Gravitation. See,